Welcome to the lesson for Physical Science 20, Chemical Reactions in the Mole. This is the lesson for the RM5 assignment, completing double displacement reactions and determining solubility. Recall that double displacement reactions are like two couples dancing together that decide they would like to switch partners with one another. Double displacement reactions always consist of two ionic compounds. Remember, the cation, which is positive, is always written before the anion, which is negative. The cation-anion combinations will switch when we go to the products. Example 1. First, we write the cation and anion in each pairing. Strontium takes a +2, chloride off the negative list is -1, sodium takes a +1, and carbonate, again off the negative list, takes a -2. I'm going to convert those into formulas. Sr2 plus goes with Cl minus, Na plus goes with CO3 2 minus. When Sr and Cl come together, the lowest common charge is 2, so I need one strontium for a +2. I need two chlorides for a -2. Na plus and CO3 2 minus, lowest common charge again is 2, so I need two sodiums that give me a +2. I need one CO3 to give me a -2. Now I'm going to write the products. Strontium, which is positive, will go with carbonate, which is negative. Sodium, which is positive, will go with chloride, which is negative. So when strontium comes together with carbonate, lowest common charge is 2, so I need one strontium to give me a +2, one carbonate to give me a -2. Sodium and chloride, lowest common charge is 1, so I need one sodium to give me a +1 charge. I need one chloride to give me a -1 charge. Remember, I always write my positive before my negative in each formula. Finally, I'm going to balance the equation. I have one strontium on either side. I've got one carbon on either side. I've got three oxygens on either side. But on the left-hand side, I have two chlorines. So I will need two chlorines on the right. When I do that, I also wind up with two sodiums on the left, two sodiums on the right. The equation is balanced. When we need to determine if the products are solid, aqueous, or liquid, this will be done with the aid of the solubility chart. We will have to determine if the products are solid, liquid, or aqueous. This will be done by referencing the solubility chart on our pink sheet. We will have to first look up the anion, then determine if it forms a solid with a cation that it has been paired with. Soluble means it dissolves in water, so it is aqueous. Hydroxide does not form a solid with lithium, sodium, potassium, rubidium, cesium, francium, hydrogen, ammonium, strontium, barium, radium, or thallium ions. Low solubility means it does not easily dissolve in water, so it forms a solid. Halides, that is iodide, chloride, and bromide, form solids with silver, lead 2, mercury 1, copper 1, and thallium ions. Write on your pink sheet a note that will remind you of this when we are doing the examples and when you are working on the assignment or writing the quiz. In some of the examples, water is produced. It is neither a solid nor is it aqueous. When water is produced, it is identified as a liquid. To finish the question, we have to determine if the products are solid, aqueous, or liquid. So we'll start with strontium carbonate. Again, we look up the anion first. So I'm looking at the row that has carbonate, phosphate, and sulfite. It says if we have lithium, sodium, potassium, rubidium, cesium, francium, hydrogen, or ammonium ion, it will be soluble. But we don't have any of those cations. We have strontium. So that means we are in the all others category. And all others are low soluble, which means strontium mixed with carbonate would make a solid. So next to strontium carbonate, I will put an S. Now I look up sodium chloride. Again, I look up the negative ion first, so I'm looking at the row that has the halides of iodide, chloride, and bromide. When mixed with silver, lead 2, mercury 1 ion, copper 1 ion, or thallium ion, it is low soluble. We don't have any of those, we have sodium, so again, we are in the all others category. And it says, in the case of a halide mixed with anything other than silver, lead 2, mercury 1, copper 1, or thallium, it is soluble, which means it is aqueous. So next to sodium chloride, I will write AQ. If we give this solution time to settle, it will look like this. And we can clearly see a solid of strontium carbonate on the bottom, and the sodium chloride would be aqueous, so it'd still be inside of the water. Again, sodium chloride would not be connected like that. Since it is aqueous, that means it's dissolved in water. So the Na plus and the Cl minus will be floating around in solution. Example number 2, write the cation and anion in each pairing. We got hydrosulfuric acid, so acid always starts with H plus. We got hydro and ic, so it's I, so it's sulfide. Barium takes a +2 charge, and hydroxide's on our negative list, and that's OH minus. Now we're going to convert into formulas. H plus and S2 minus, lowest common charge is 2, so I will need 2 H's to give me a +2 charge and 1 S to give me a -2 charge. Barium hydroxide, also lowest common charge is 2, so 1 barium gives me a +2 charge, 2 hydroxides gives me a -2 charge, so Ba bracket OH bracket 2. Now I'll write the products. That means that H plus is going to go with OH minus, and Ba2 plus is going to go with S2 minus. So first we'll do barium sulfide. So Ba has a +2, S has a -2, lowest common charge is 2, so I just need one of each to give me a +2, -2. And when H plus and OH minus come together, that would make HOH, and we don't write it as HOH, we write it as H2O. And to finish off the equation, I would have to balance it. I've got 1 sulfur on either side, I've got 1 barium on either side. What doesn't balance out is my oxygen and hydrogen. Right now I have 2 oxygens on the left-hand side, so that means I will need 2 oxygens on the right-hand side, so I will require 2 water molecules. Just to check, when I look at the hydrogens, I have 4 on the right. I also have 4 on the left, 2 in the hydrosulfuric acid, 2 in the barium hydroxide. To finish the question off, we will have to determine if the products are solid, aqueous, or liquid. So we'll start with barium sulfide. I'll look down the anion list until I find sulfide. I see that barium is listed, and it says when barium is with sulfide, it is soluble. So I'll write AQ next to BAS. And then H2O, that's always a liquid. And that was quite boring because nothing really happened. I've got water inside of the beaker. I have barium sulfide, which is aqueous. So that means all that's inside of the beaker is Ba2 plus floating around, S2 minus floating around, and the beaker is full of water. Now for example 3. Again, we always write the cation and anion in each pairing. So copper 2, remember the Roman numeral is always the charge. So we've been told copper has a +2 charge. Nitrate is on our negative list, that's NO3 minus. Ammonium, we will not find it on the periodic table. It is one of our special cations. It's on our formula sheet in one of the data tables, the one listed as common positive ions. So ammonium is NH4 positive. And then phosphate, again, we always have a positive on the front, negative on the back. When we're looking at these formulas, I look up phosphate on the negative list, and that's PO4 3 minus. Now I'm going to convert into formulas. Copper 2 and nitrate are going to come together. That's a +2 minus 1, so lowest common charge is 2. So I will need 1 copper and 2 nitrates so that the charges will balance out. I also have ammonium and phosphate coming together, a +1 and a -3. So the lowest common charge is 3. So I will need 3 ammoniums and 1 phosphate to give me a +3 -3. And that is going to turn into, well, Cu2 plus will go with phosphate, and NH4 plus will go with NO3 minus. So when copper 2 and phosphate come together, that's a +2 and a -3, the lowest common charge is 6. So I will need 3 coppers to give me a +6. I will need 2 phosphates to give me a -6. And when I bring ammonium and nitrate together, of course, I always write the positive before the negative. I got a +1, -1, it already balances out. So ammonium, I need 1 of those to give me a +1, and then nitrate, I just need 1 of those to give me a -1. It is balanced out. Now, I have to balance the overall equation. I'm going to start by putting a 1 by the most complicated formula, and I would say that that is copper 2 phosphate. Now to start balancing, I'm going to start with the coppers. On the right-hand side, I have 3 coppers. That means I will need 3 coppers on the left-hand side, so I will place a 3 in front of the copper 2 nitrate. Now, I can balance out the phosphorus. I have 2 P's on the right-hand side. That means I will need 2 P's on the left-hand side, so I will put a 2 in front of the ammonium phosphate. Now I could balance out the oxygens now, but they are located in multiple different spots, so I decided to balance the last formula there. I will use the hydrogens. So on the left-hand side, on the reactant side, I have 4 hydrogens in brackets. I will have to multiply that by 3, so that gives me a total of 12 in the formula. There was a 2 placed in front of the formula, so I'm going to have to multiply that 12 by 2. So I have a total of 24 hydrogens. So to get 24 hydrogens on the right-hand side, on the product side, I will need 6 ammonium nitrates. The equation is now balanced. Now let's determine if the products are solid, aqueous, or liquid. We'll start with copper 2 phosphate. So we go down the anion list and look for phosphate. And it says that it is soluble with lithium, sodium, potassium, rubidium, cesium, francium, hydrogen, and ammonium ion. And we don't have any of those cations. Our cation is copper 2 ion, so it falls into the all others category. And all others are low soluble, so we write a solid next to copper 2 phosphate. Now we're going to look up ammonium nitrate. So we go down the anion list and find nitrate. And it says essentially all cations, when mixed with nitrate, are soluble. So we'll write an AQ next to ammonium nitrate. We take the 2 chemicals that have been dissolved in water, add them together, and it becomes cloudy because a solid has formed. If given enough time to settle out of solution, we would see the solid fall to the bottom, and that would be our copper 2 phosphate. And at the top, we would have a solution that has ammonium nitrate dissolved in it. So that means the NH4 plus and NO3 minus ions are floating around inside of the liquid water layer. And that brings us to the end of the lesson for RM5. You can now begin working on the RM5 assignment, and I'm just asking you to do a solid job of that. Get it? Solid?